Welcome dear learners. We are continuing Unit 1, Chemistry as a Science Discipline and Scientific Analysis. In the present module, we are discussing accuracy in quantitative chemical analysis. Here we consider definition of accuracy, accuracy versus precision in quantitative chemical analysis, methods of representing accuracy, absolute error, relative error, and finally problems based on errors, accuracy and precision. So, moving on to definition of accuracy. We all familiar with the term accurate result, inaccurate result, precision, etc. All these terms are highly important as far as quantitative chemical analysis is concerned or every kind of measurement in science is concerned. So, we have to consider accuracy and precision and various factors influencing accuracy in more detail. First of all, definition of accuracy. Accuracy refers to the closeness of a measured value to a standard or known value. For a very simple example, you know about the acceleration due to gravity. Its theoretical value is 9.8 meter per second. So, you are performing an experiment that is nothing but the simple pendulum experiment and measure the value of acceleration due to gravity by experiment. Suppose you get a value 9.79 instead of 9.8. Remember, the value 9.8 is the true value and you got a value which is 9.79. The observed value is very close to the true value because there is very small difference between the actual value 9.8 and the observed value 9.79. So, we can say that your measurement is more or less accurate. If you are getting 9.8 itself, your value will be more accurate. Now, we can enter into more details of the concept accuracy. Accuracy measure, it is a measure of the correctness of the result. More accurate means there is very close agreement between true value and the observed value. Now, we can illustrate the concept of accuracy by using certain examples. Consider the determination of concentration of sodium hydroxide in a given solution. Suppose the true concentration of NaOH in the solution is 0.500 molar. This is the true value or correct value. Now, an analyst, a chemist use volumetric analysis or a titration method to determine the concentration of NaOH solution. And he got the values 0.498 molar, 0.503 molar and finally 0.501 molar in 3 repeated measurements. And the measured values, that is 0.498 molar, 0.503 molar and 0.501 molar are very close to the true value which is previously mentioned as 0.500 molar. And we can say that this method, the chemist adopted a method which is accurate. Moreover, we can consider the value 0.501 molar as the more accurate value because 0.501 is very close to the true value, that is 0.500 molar. Now, another example of accuracy is here. If in a lab you obtain a weight measurement of 52.2 gram for a given sample of NaCl. You measured a sample of NaCl sample weight. Then you got the value 52.2 gram as your weight. But the actual or known weight of the sample is there and it is equal to 80 gram. Then your measurement is not accurate. Why we can call this measurement is not accurate? The reason is simple. The actual weight is 80 gram, but you got a weight which is 52.2, that is far deviated from the actual value or true value. This is, in this case, your measurement is not closer to the known value, and hence your measurement is an inaccurate measurement or not accurate measurement. Now, accuracy tells you how correct your measurement is compared to the standard or known value. Now, we are considering another important aspect which is closely related to the concept of accuracy. This is also more important as far as quantitative chemical analysis is concerned. The concept is nothing but precision. Precision refers to how consistent repeated measurements are with each other, regardless of how close they are to the true value. Suppose I measured acceleration due to gravity by simple pendulum experiment thrice. 3 times I have measured the acceleration due to gravity by using the very simple pendulum experiment. So, I got 3 values. Let the 3 values obtained are 9.6, 9.61 and 9.6 again. These 3 values, the obtained 3 values are 9.6, 9.61 and again 9.6. The 3 values are very close to each other, such that we can say that there occurs some precision in the values. There occur closeness between the observed value. But that closeness never implies that the result is true. We know the actual value is 9.8, but I got 3 values as 9.6, 9.61 and 9.6 again. So, these 3 values are very close to each other. So, these 3 values can be considered as precise values, but these precise values never implies accuracy. Now, we can illustrate the concept of precision by taking this example. Let us consider the determination of the concentration of NaCl in a solution. That is, you are provided with a sample of NaCl or NaCl solution. You are going to determine its concentration by some titration method or some quantitative analysis procedure. And suppose prior to starting the experiment, I gave the information that the true concentration of NaCl is 0.500 molar, and a chemist use simple titration method to determine the concentration and gets 3 values in his 3 set of experiments. The 3 values obtained are 0.475 molar, 0.476 molar and 0.474 molar. Now, look at these values very carefully. We can arrive at the conclusion that the measured values are very close to each other. 0.475 is very close to 0.476, which is also close to 0.474. So, the measured values are very close to each other, indicating high precision between the values. Measured values, however, deviate significantly from the true value, which is 0.500 molar, and this method is not accurate. So, the actual concentration is 0.500 molar. You got 3 values. The 3 values are very close to each other, and hence there is precision or high precision in the set of observations, but these values are far away from the true concentration of 0.5. So, the method you adopted is inaccurate or not accurate, but you got result which is highly precise. This about the concept of precision. Now, there is another example to repeat the concept of precision, that is, if a balance consistently measures the mass of an object as 5.00 gram, 5.01 gram and again 5.00 gram. The measurement is precise. Why this set of measurements is precise? This is because there is minimal variation between the values. Look, 5.00 is very close to 5.01. Yes, again the third measurement is 5.00. So, these three values are very close to each other, which indicate a high degree of precision. That is, the variation is minimum. Variation between the values is minimum. Now, precise values may or may not be accurate. That is, precision doesn't implies accuracy. Suppose in the previous example what I mentioned, I measured acceleration due to gravity thrice. The true value I know it is 9.8 meter per second, and then I got to three values as 9.6, 9.61 and again 9.6. But 9.6 range is different from far away from 9.8. So, the measured values are not accurate. However, in certain other cases, if I go to the values as 9.79, 9.8 and again 9.79, then I can say that the values are precise as well as accurate. So, you have to keep the most important point in your mind, that is precise values may or may not be accurate. Sometimes it may be accurate, sometimes it may not be accurate. That about the concept of precision. Now, precision indicates the reproducibility or reliability of measurements. This point is also important, reproducibility. Suppose I measure once by using an instrument. If I repeat the experiment, if I get the same value, then there is reproducibility, or we can, the instrument is said to be more reliable. Now, the most important part of this discussion is here, that is, we are comparing and contrast the two concepts, that is accuracy and precision. Hence, our title is accuracy versus precision. How accuracy related to precision, or is there any connection, such that we are going to finalize the relation between accuracy and precision, or we have to make the things more clear about the concept of accuracy and precision. So, accuracy versus precision. Accuracy and precision are very similar in the fact that they both refer to measurement quality, but they are very different indicators of measurement. These two terms closely related because these two terms are related to measurement of a quantity. However, they are very different indicators of measurement. Precision indicates reproducibility of the measurement. However, accuracy simply represents the correctness of the measurement. Precision does not imply accuracy. Experimental measurement may show first chance high accuracy as well as high precision. Suppose you are doing an experiment, you make some measurements, the measurements may be highly accurate as well as highly precise. These results are close to both as well as which are close to the true value. So, you get a set of values which are very close to each other. That means the values are precise and also the values are close to the true value or experimental value. In such a case, you can say that your measurement is highly accurate and highly precise. Now, moving on to the second chance, high accuracy and low precision. You took some measurements which the values are very close to the true value, but the results have some variation. So, in that situation, precision is low and accuracy is very high. And the third chance is here, third possibility is here, low accuracy and high precision. In certain measurements, you will get similar values whenever you are taking the reading or measurements. So, the values are precise, but the obtained values are far away from the true value. So, in that situation, the accuracy is minimum. This situation refers low accuracy and high precision. And finally, there is one more chance, that chance is low accuracy, low precision. What is meant by this? Whenever we are taking some measurements, the obtained values have no precision because there is huge variation between the values. Moreover, the obtained values are far away from the true value also. In that situation, we can say that accuracy is low and precision is low, that is the measurement is low accurate and low precise. Such an analysis is not recommended in analytical chemistry because that always give erroneous, highly erroneous results. So we considered 4 different cases related to accuracy and precision. High accuracy, high precision, high accuracy, low precision, low accuracy, high precision, low accuracy, low precision. So these are various possibilities as far as a measurement in quantitative analysis is concerned. Now, this is a pictorial illustration of the 4 situations we have discussed so far. The first case represents high accuracy and high precision. The second situation shows high precision. The last part is high accuracy, high precision, and the final part is low accuracy and low precision. The 4 situations we have discussed so far is consolidated in the form of a diagram is here. This about the comparison between the concept of accuracy and precision, that is nothing but accuracy against precision. Focusing on the methods of representing accuracy. We know that accuracy tells us how the observed value are close to the true value or actual value. So we can represent accuracy by using different statistical or different methods. We are now focusing on such methods for representing accuracy. That is methods of representing accuracy. In measurements, any difference between measured value and the true value is termed as an error. Accurate measurements are associated with the minimum error. We know about accuracy. For an accurate measurement, the true value and observed value are very close. So, the difference between them is minimum. The difference between experimental value and the true value is known as error in quantitative analysis. Higher the error, less accurate will be the measurement, or accuracy and error shows inverse relation to each other. Hence we can say that accurate measurements are associated with the minimum error. Now, representing accuracy involves quantifying how close a measured value is to the true or accepted value. Thus, accuracy of a measurement can be expressed in terms of errors. I mentioned the fact that error and accuracy shows inverse relation to each other. A more accurate measurement is less erroneous and vice versa. That is, we can express accuracy in terms of errors. Now, there are several methods commonly used in chemistry and scientific fields to represent accuracy. Some important methods are described here. First one, absolute error. I mentioned the fact that you can represent accuracy of a measurement in terms of errors, because there is inverse relation between accuracy and errors. Some methods are, first one, absolute error. What is meant by absolute error? The difference between the measured value and the true value. Here we are taking only the difference. That difference is termed as absolute error. We can come into more details of the absolute error with the problems in the coming slides. And the second possibility is relative error. The ratio of absolute error to the true value is expressed as a percentage in general. That is called relative error. So, what is meant by relative error? You have to first calculate the absolute error. Absolute error is the difference between observed value and the true value. Then it should be divided with the true value, and for convenience this quantity should be multiplied with the 100 to express it as a percentage. That is called relative error. Now, percentage accuracy is another possibility to represent accuracy. Percentage accuracy represents how close the measurement is to the true value, which is expressed as a percentage of the true value. Similar to error percentage, you can also represent percentage accuracy. So, absolute error, relative error and percent accuracy are various important methods to represent accuracy of a measurement. Now, mean accuracy is a concept which is less common in practice, but even though this is the situation, we can also represent the error by using the term mean accuracy. Mean accuracy is otherwise called average of measurements. When multiple measurements are taken, the average of the measurements can be compared to the true value to evaluate overall accuracy. So, in the case of multiple measurements, it is possible to express accuracy as a parameter, that is nothing but mean accuracy, but we are not commonly use this concept. We are commonly using the first two, that is nothing but absolute error and relative error. The last two parts, that is percentage accuracy and mean accuracy, are not commonly used concept to represent the accuracy. Now, confidence interval, there is a possibility. This chance is also very rare when compared with the first four methods. In very important trace analysis, we are using another chance to represent the accuracy, that is nothing but confidence interval. You can study more about the concept of confidence interval in your higher classes, but I put it here due to the sake of convenience to just familiarize you about the concept of confidence interval. To simply go through the definition, the confidence interval provides a range within which the true values is expressed to lie with a certain probability. Example, 95% confidence interval. We can set to confidence interval, confidence limit, etc. This concept is far beyond your syllabus. I just put it to just familiarize the term. This is also a possibility to represent the accuracy of a measurement. Now, we are going to consider absolute error in more detail. In the coming few slides, we are discussing about more details of absolute error and relative error. We studied the fact that there are several ways to express the accuracy of a measurement. Can you remember such methods? The methods include absolute error, relative error, percentage accuracy, confidence interval, etc., etc. But I mentioned that the first two methods, that is absolute error and relative error, are most promising methods, most commonly used methods. So, we are entering into more details of the concept absolute error. Absolute error measures the difference between the measured value and the true or accepted value. X measured is the measured value, X true is the true value. Hence, the mathematical expression for absolute error is the modulus of the difference between them. We are considering only the positive quantity. That is why here there are two the quantity is placed between modulus. So, absolute error is modulus of X measured minus X true. That is, absolute error is the modulus of the difference between experimental value or measured value and the true value. It provides, this absolute error provides a direct quantification of deviation without considering the scale of the measurement. Always this absolute error is expressed as a positive quantity because we are taking only magnitude of the difference between experimental value and the true value. This absolute error represents the actual amount of deviation from the true value. Now, this is an example for you which is relating to absolute error. If the true weight of a substance is 50 gram and a balance measure it as 49.6 gram, then the absolute error is the modulus of the difference between these two quantities, that is 49.6 minus 50.0, and the absolute error is 0.4 gram. Moving on to the next concept, that is another method to express accuracy, which is nothing but relative error. Relative error expresses the absolute error, that is the difference between observed and actual value, as fractions or percentages of the true value. It provides a sense of the error's significance relative to size of the true value. Now, the relative error is represented mathematically like this: modulus of x measured minus x true divided by true value. You know the numerator, which is equal to absolute error. So, relative error is equal to absolute error divided by true value. It can be expressed as a percentage, such that relative error percentage is equal to modulus of measured value minus true value divided by true value into 100. So, first one is expression for relative percentage, the second one is expression for relative error as percentage. Now, this relative error accounts for the scale of the measurement, which make it more meaningful for a comparison. This relative error is always expressed as positive value, unitless in fractional form, but expressed as a percentage when multiplied with 100. In the previous expression, we learned that absolute error is only the difference. Absolute error divided by true value get the expression for relative error. If you are taking relative error as such, it is dimensionless or unitless. But if you express it as a percentage, then there will be unit. Now, example for relative error. If the true length of an object is 100 centimeter and a measurement gives 98.5 centimeter, then absolute error is equal to 98.5 minus 100, that is equal to 1.5 centimeter. Relative error percentage is equal to absolute error 1.5 divided by the true value 100 multiplied by 100. So, you are getting the result as 1.5 percentage. This about the concept of relative error. Now, we are moving on to some important numerical problems based on the concept we mastered, that is the concept of error, accuracy, precision. Method of expressing accuracy, two methods, that is absolute error as well as relative errors. We can enter into the problems. The first problem, the volume of a liquid is 26 ml. A student measure the volume and finds it to be 26.2 ml in his first measurement, 26.1 ml and 25.9 ml, and finally 26.3 ml in his first, second, third and fourth trial. So, he made 4 trials, he got 4 values, the values are shown here. Which of the following statement is true for this measurement? This is about the question. So, hope the question is more clear to you. The actual volume, the volume of a liquid, the true volume is 26. During measurements, a candidate got 4 values. The 4 values are here, and the question is about the statement which is more apt with this measurement. Now, let us look at the options. They are neither precise nor accurate. They have poor accuracy, they have good precision, they have poor precision. Moving on to this concept, the best suitable one is they have good precision. 26.2, 26.1, 25.9 and 26.3. So, this indicates that they have a good precision. They have good precision is the best choice, is the most appropriate answer to the concerned problem. Now, we can discuss the next problem. The volume of a liquid is given as 20.5 ml. Which of the following sets of measurement represents the value with a good accuracy? Some sets of values are here. The first set of values in a set of measurement. In each set there are 4 values. You have to carefully analyze the 4 sets of values and you have to answer the question. The question is, which of the following measurement represents the values with good accuracy? So, you have to keep in mind the fact that which of these set represents very closeness to the true value. True value is given here, it is equal to 20.5. So, on careful analysis, you can arrive at the conclusion that the option D, that is 20.2, 20.5, 20.3, 20.1 ml. Look at the standard value, that is 20.5. In all these sets of values, the values are very close to 20.5. 20.2, 20.5, 20.3, 20.1, etc. So, the last set, that is option D, represents a set of measurements with good accuracy. Now, we are discussing another problem. The true value of a quantity, a physical quantity, is 50. If a person measures 48, 49, 50 and 51 in repeated trials, what we can conclude about the measurements? You look at these values and the true value, which is 50, and which conclusion you can make about this measurement. These are the options in front of you: high accuracy, low precision, high accuracy, high precision, low accuracy, both high accuracy and precision, low accuracy and low precision. On careful analysis, you can say that both high accuracy and precision. 50 is the value, 48 to 49, 50 and 51, there is difference of 1 unit between each other, 2 adjacent values. So, the values are said to be precise and these values are experimentally more close to the true value, that is 50. So, you can say that the values are accurate also. So, there occur high accuracy and high precision. That about this problem. Now, moving on to another problem. If the true value is 25.0 and a measurement reads 24.8, what is the percentage error? You know, percentage error is nothing but relative error expressed as a percentage. You know the expression for the percentage error or relative error as percentage equal to absolute error divided by true value multiplied with 100. So, what is absolute error? It is the modulus of true value and the experimental value. So, you have to first take the difference between these two values. It will give you, its modulus will give you the absolute error. You have to divide absolute error with the true value, that is 25, and multiply with 100 to get to the final result. So, we can proceed to the result. The options are also given here. You have to find the result. The result is clear. It is option A. Option A is obtained because you have to first find out the difference between these two values, 25 and 24.8. The difference is 0.2. That 0.2 should be multiplied with 25 and multiplied with 100. So, the result is nothing but 0.8%. Now, another problem. If the absolute error in a measurement is 0.05 and the true value is 2.5, what is the relative error? Absolute error is here, you have to find out the relative error. So, 0.02, 0.50, 0.025 and 2 are the results are the choices here. You have to find the right answer based on the expression you have studied, and it is clear that option C will be your right answer. Absolute error is given and true value is given. then you have to divide this absolute error with true value and multiply with 100. So, if you are avoiding multiply with 100, you will get the direct relative error. If you multiplied with 100, you will get the relative error percentage. So, you can do it, and in the present case the value is option C, that is nothing but 0.025. This is simply not the percentage, this is equal to 0.05 divided by 2.5, that is absolute error divided by the true value. Now, the last problem, the measured value of a mass is 50 kilogram and the relative error is 0.04. What is the absolute error? This is by using the same expression you can find out this value. The options are also given here. The true value is 50 and relative error is 0.04. So, absolute error divided by 50 equal to relative error. Absolute error divided by true value, that is 50 equal to 0.04. This is relative error. So, in order to find out absolute error, you have to cross multiply these two quantities, and 50 into 0.04 will be your result, and the answer is option A, that is 2 kilogram. So, you have to multiply relative error with the true value to get the absolute error. That all about the presentation. Have a nice learning experience. Thank you.